So, 117 question number is on your screen. Gadolinium belongs to 4F series, its atomic number is 64. So, which of the following is the correct electronic configuration of gadolinium? So, now we are moving to the solution part. So, for this you should know the xenon atomic number and it is coming as 54. Okay. Now, just try to add on, see 8, 9, 10. So, this is also give you the 64, but here 4F8 will be mentioned, here 4F7 will be there, and 5D1 and 6S2, here 4F6 and 5D2 6S2. So, if you see the option number 3, okay, option number 3, if you see here xenon is 54 and 7 plus 1 plus 2, that is your 7 plus 1 8, 9 10, 10 plus 4 is equal to 14 and 6 64. So, option number 3 is the correct configuration of your 117 question number. So, 118 question number is on your screen. So, which of the following is not the product of dehydration of the given compound? So, now we are moving to the solution part. So, in this question the reactant whatever they are mentioning, this reactant derivative correction will be there. So, here one more CH3 group should be there. So, how it is look like this. Your OH and this. So, this is the reactant. Okay. So, there is a little bit correction. So, please make the correct. Okay. Now, what will happen? Dehydration means we have to remove a water molecule. So, now first H plus will be there in water. So, this lone pair will be abstract by this H plus. So, you are end up with OH2 positive. So, this is nothing but this is your water molecule. So, we can easily remove this water molecule. So, as a result what you are obtaining? You are obtaining this kinds of intermediate. So, see this is the carbocation, okay. This is carbocation. Now, after this one whatever the product we are obtaining, that is the rearrangement of this carbocation. Now, the first product we are obtaining here is this one, this, here this and this. So, this is also a kind of product. Now, one more rearrangement if you do here. So, how we will obtain here? If you remove hydrogen from this side. So, here minus sign will be generated and this minus and plus will form the bond. Now, if I am removing here also CH3 will be there. So, one hydrogen if you remove it from here, you are obtaining a product like this. Okay. If I am removing hydrogen from here, so I am just mark it here with a different color. So, this is A pathway, this is B pathway, this is C pathway. So, this product you have to obtain from the A pathway, this product we have to obtain through the B pathway. Now, here also CH3 will be there. Now, if this one will be removed, sorry not for this one, from here, see here also 2 hydrogen will be there. So, if I remove hydrogen from here and rearrangement, we are obtaining here so, if I remove hydrogen from here, we are obtaining so this is here another product. So, A product is given here, this is also possible, B product means this one is also possible. Now, C product this one is also possible, but here they are asking the not the product. So, which one we are getting? Option number 2. option number 2 is not our product. So, option number 2 is the correct answer of your question number 118. So, now we are moving to the next question, that is question number 119. So, question number 119 is on your screen. A gas such as carbon monoxide would be most likely to obey the ideal gas law at. So, this question is come from the states of matter of your class 11 NCERT. So, now we are moving to the solution. So, here they are asking most likely to obey the ideal gas. Okay. So, what is the following order they follow if a gas should follow a ideal gas equation? Then there will be a higher temperature and pressure should be low. Okay. So, this should be maintained if anyone should obey this ideal gas law. Okay. It should require a high temperature and it required a low pressure. Now, if you see in the option number 1 where they are giving high temperature and your low pressure. So, this is the correct option of your question number 119 and it directly come from the NCERT statements, okay, of your states of matter. So, now we are moving to the next question, that is question number 120. So, question number 120 is on your screen. The stability of +1 oxidation state among aluminum, gallium, indium and thallium increases in the sequence. So, this question is come from your S and P block element of your class 11 NCERT. So, now we are moving to the solution part. So, if you see this one is boron series. So, bengan, alu, gajar in thela. So, how to remember this one? Simple mnemonics, bengan, alu, gajar in thela. Okay. So, remove this part, we required only aluminum, gallium, indium and tellurium. Okay. Sorry, this should TL. Now, when you down the group, what will happen? They ask you +1 oxidation state. So, when you going down the group, your +1 oxidation state will be stability will be increases. Okay. Now, what is the reason? The reason is your inert pair effect. Okay. Due to inert pair effect, the +1 oxidation state down the group it will be increases. So, what order you should get? Aluminum, then gallium, then indium and then your thallium. So, now see option number 2 which follow this order and this is the correct answer of your question number 120. So, question number 121 is on your screen. So, what is the pH of the resulting solution when equal volumes of 0.1 molar NaOH and 0.01 molar of HCl are mixed? So, now we are moving to the solution part. So, if you see here, first of all we have to find out the formula which we are going to use here. So, N1 V1 minus N2 V2 is equal to N3 V3, or you can say N total V total. Okay. And this N3 is nothing but this is the concentration of OH minus. So, now if you see the formula N1, what is the value of N1? That is 0.1, and what is V1? V1 here is 1 because they are saying that equal volumes. So, 1 is to 1 we can say. For N2 we are taking as 0.01 and V2 value is 1 again, and what is the total volume? 1 plus 1, that is 2, is equal to N3, and N3 is nothing but this is the OH concentration. Now, if you solve this one, OH concentration is equal to 0.09 divided by 2, and if you are solving this one, it is coming as 0.045. Okay. So, this is your OH concentration. Now, if I told you to find out the POH, so how much it will coming here, minus log of OH ion concentration. Now, what is the OH concentration value is 0.05 minus log of 0.045. Now, when this log of 0.045 is given, if you solve this part, your value is coming as nearly 1.35. Okay. So, this is the pOH value. Now, for pH the formula is, so pH plus pOH is equal to 14. So, pH is equal to 14 minus pOH. What is the value of pOH? It is coming as 1.35. So, your answer is coming as 12.65. So, if you see the pH 14 minus 1.35 and you get your answer as 12.65. So, 12.65, your option number 1 is the correct answer of your question number 121. So, now we are moving to the next question, that is question number 122. So, question number 122 is on your screen. Strong reducing behavior of hypophosphorus acid is due to. So, now we are moving to the solution part. So, if you see, this is hypophosphorus acid and what is the structure is P double bond O, H, H and OH. Now, see what is, why the reducing behavior. Okay. See, presence of one OH group and 2 pH bond, yes. So, this is the reason that H3PO2 is a strong reducing behavior. So, option number 1 is the correct answer of your question number 122. So, now we are moving to the another question, that is question number 123. So, question number 123 is on your screen. The number of structural isomers possible from the molecular formula C3H9N is. So, now we are moving to the solution part. So, if you see, they are giving the molecular formula is C3H9. So, let us try to draw the structures. Okay. So, 1, 2, 3 and here you have to get NH2 group, CH2, CH2, CH3. So, this is nothing but this is your primary amine. Now, one more way we can draw this one, CH3, CH, CH3, NH2. So, these two are your primary amine. Okay. So, now one more we can draw NH, here this is CH3, CH2 and your CH3. So, now see 1, 2, 3, number of hydrogen 9, 3, 4, 5, 6, 7, 8 and 9. Okay. So, this is nothing but this is your secondary amine. Now, CH3 and CH3 and CH3. Now, if you see 3 plus 3 6, 6, 7, 8, 9. So, this is your tertiary amine. So, how many structures is possible? 2 primary amine, 1 secondary amine and 1 tertiary amine. So, 2 plus 1 3, 3 plus 1 4. So, 4 isomer is possible of this structure. So, answer number 1 is the correct answer of question number 123. So, now we are moving to the next question, that is question number 124. So, question number 124 is on your screen. Which of the following statement is not correct for a nucleophile? So, now we are moving to the solution part. So, first of all, if you see the nucleophile, so they are the electron rich species. Okay. So, we can write like this. So, they always have a tendency to donate. Okay. And when they are tendency to donate, so they are not a tendency to donate means they can easily give the electrons because they are electron rich species. Okay. So, when they have a tendency to donate, so we can say they are Lewis base because base always have a tendency to donate, where acid they are having tendency to accept it. Always remember A acid, A acceptor, and the vice versa is for base. Now, let us see the statements. So, nucleophile is a Lewis acid. Okay. This is the correct statement. sorry, nucleophile is a Lewis acid they are mentioning, but already I am mentioning Lewis base. So, here they are asking not correct, marked it not correct. So, your option number 1, this is a not correct statement. So, option number 1 is the correct answer of your question number 124. So, question number 125 is on your screen. Number of possible isomer for the complex, and that given complex they are mentioning here. So, now we have to move on to the solution part. Okay. So, this is the complex they are given. So, first of all see what is the coordination number here, it is 2 into 2, that is a bidentate ligand ethylene diamine. So, 2 into 2 4 plus 2, that is 6. So, coordination number is 6. So, how it's look like here, this one cobalt and here ethylene diamine, this one is present. So, this one is a cis isomers. So, it is optically active. Okay. Sorry, this is optically inactive. This is trans isomer. Okay. Opposite side. So, this is optically inactive. So, this is also possible. So, one structures we are getting from this transform, that is transform. Okay. I am written here as a transform. Trans 1. So, now see another cis form how it look like. Okay. So, CO. So, if I am putting here this one and another one is this one, and the similar way we can write this one is another. So, this is cis form. So, if I draw little bit on, okay, if I am draw here, so this is ethylene diamine and here also ethylene diamine. Now, here this Cl and Cl is present. So, this is one cis form, and similarly if I draw here cobalt. So, what you get here En on this side. So, here En in cis you are getting two form. Okay. So, cis we are getting two structures. Okay. So, this is optically active. Okay. So, this is optically active. So, if you see 1 trans 2 trans, so how many total isomers? 3 isomers. So, if you see the option number 3 is the correct answer of your question number 125. So, now we are moving to the next question, that is question number 126. So, question number 126 is on your screen. So, which is the correct order of increasing energy of the listed orbitals in the atom of titanium? So, now we are moving to the solution part. So, if you see here, they ask you the correct order. So, we first of all see the n plus L values. Okay. Who having the lower n plus L value, that will filled first. Okay. Lower value we have to find it out. So, here first of all 3s, 3p, 4s, 3d. Okay. Only these orbitals they are given. So, see, for 3, for s value, for s the L value is 0. So, it is coming as 3. So, here again 3, the L value for p is 1, this is coming as 4. For 4s n value is 4 and L value is 0. So, it is coming as 4. Now, so for 3d n value is 3 and d value is 2. So, 3, 4, 5. So, definitely this will filled last. Okay. Now, if you see in option number 3 is not possible because here it is given as 4s. Now, remaining all are 3d. And if you see the 3s, it is having a lower n plus L value. So, it will fill fast. Now, if you see among this all, only option number 1 and option number 4 3s will given first, option number 2 4s. So, 4s is not possible. So, option number 2 also we can neglect it out. Now, when this n plus l value is same, we have to see the n value, okay, who having the lower n value. So, 3p, right, 3 having the lower n value. So, after 3s it will be filled by 3p. Now, if you see 3s, it will again given by 4s. No, this is not possible. After 3s we have to move on to 3p. After 3s, yes, here it is given is 3p. So, option number 4 is the correct answer of your question number 126. So, this question is come from your structure of atom of class 11 NCERT. So, now we are moving to the next question, that is question number 127. So, question number 127 is on the screen. In an SN1 reaction on chiral center there is. So, this is a very easy question. Now, we are moving to the solution part. So, basically they ask you the in SN1 reaction what is the stereochemistry of the product. So, if you see 100% racemium, no. Option number 2, if you see inversion more than retention leading to a partial racemization, yes. Option number 2 is the correct statement of your question number 127. So, this is a substitution reaction. We know the substitution is 2-1, one is SN1, another one is SN2, and both are very important. Okay. So, this one is given in your 11 NCERT book. Okay. 11 NCERT they are given this part. So, please study one, do not neglect this SN1 and SN2. So, here what you got, option number 2 is the correct answer of your question number 127. So, question number 128 is on your screen. The vacant space in BCC lattice unit cell is. So, this question is come from your solid state of your class 12 NCERT. So, now we are moving to the solution part. So, if you see in BCC lattice, the packing efficiency is 68%, okay. And if packing efficiency means the space which is occupied by your atoms, okay, in easiest terminology. This is not the exact definition, but easiest terminology, okay. So, whatever packing efficiency here you are getting is 68%. Now, for vacant space, 100 minus 68 you are getting as 32. So, this 32% is your empty space or vacant space. Now, if you see option number 4, 32% is the correct answer of your question number 128. So, now we are moving to the next question, that is question number 129. So, question number 129 is on your screen. The heat of conversion of carbon to CO2 is minus 393.5 kilojoule per mole. The heat released upon the formation of 35.2 gram of carbon dioxide from carbon and oxygen gas is. So, this question is come from your thermodynamic chapter of your class 11 NCERT. So, now we are moving to the solution part. So, first we write down the equation, carbon plus oxygen, it will give CO2, and how much they are given the value of this one, this is delta HF is given as minus 393.5 kilojoule per mole. So, if you see the molecular weight of carbon dioxide, it is coming as 44 gram, means 44 gram CO2, how much heat will be released, that is minus 393.5 kilojoule per mole. Now, for 35.2 gram of CO2, how much it will be released, minus 393.5 into 35.2 divided by 44 gram. And when you solve this multiplication or solve this mathematical expression, your answers is coming in a negative form. So, first let the cancel out which is given in a positive format. See, this is positive, so we can neglect it out. Now, the value after solving this, it is coming as 315 kilojoule, okay. Just solve this mathematical expressions and you will get your answers. So, if you see in the option 315, option number 1 minus 315 kilojoule is the correct answer of your question number 129. So, now we are moving to the next question, that is question number 130. So, question number 130 is on your screen. Aqueous solution of which of the following compound is the best conductor of electric current? So, now we are moving to the solution part. So, if you see, they asked about the which is the best conductor for electric current. For this, which one is completely dissociate into ions. So, these are or those are the best conductor of electric current. Now, if you see among this all, if you see HCl, that is hydrochloric acid, we all know it is completely dissociate because it is a strong acid, H plus and Cl minus. So, this is the best conductor for electric current. So, option number 2 is the correct answer of your question number 130. So, now we are moving to the next question, that is question number 131. So, question number 131 is on your screen. The oxidation of benzene by vanadium pentaoxide in the presence of air produces. So, now we are moving to the solution part. So, what happened when benzene is react with your V2O5? It will give your maleic anhydride. So, what is the structure of maleic anhydride? So, this is the structure of your maleic anhydride. Now, if you see in the option number 2 is the correct answer of your question number 131. So, question number 132 is on your screen. Reaction of a carbonyl compound with one of the following reagents involves nucleophilic addition followed by elimination of water. The reagent is. So, this question is come from your aldehyde chapter of your class 12 NCERT. So, now moving to the solution part. So, what will happen? They asked about the carbonyl compound. So, let us draw the carbonyl compound in a simple form. Okay, this is a carbonyl compound, and they asked about the reaction of carbonyl compound involve nucleophilic followed by elimination of water. They asked about the reagent. Okay. So, the reagent is NH2R. Okay. So, this is basically called as amine. So, what will happen? This one will going attack on this carbon because it is a electrophilic carbon, and this bond will be shifted on this side. So, what you are getting? You are getting this type C, here you are getting O, and from this part I will writing like that NH and H. Okay. So, when it will be attack on this side, this will be going this side. So, here NH, H and R. So, this contain a negative charge and here is the positive charge. So, it will abstract this proton and this again go to the nitrogen. So, what you are obtaining here? You are obtaining here as this kind of product OH, NH, R. Now, what will happen if this lone pair again it will abstract this proton and nitrogen here abstract this proton and this lone pair will be left here and this one will be go as a liberation of water. What you are obtaining from this part? You are obtaining like C double bond, because after removing this part here positive will be coming and here negative. So, you are obtaining this kind of structure. Okay. So, this part is nothing but addition elimination mechanism. And what is the options? If you see a Grignard reagent, no, this is not possible. Hydrogen in presence of frivolly acidic solution, yes. So, this is the correct option of your question number 132, and this question is come from your aldehydic chapter. Okay. aldehydic chapter of your 12 NCERT. So, now we are moving to the next question, that is question number 133. So, question number 133 is on your screen. So, method by which aniline cannot be prepared is. So, this question is come from your nitrogen containing compound of your class 12 NCERT. So, now we are moving to the solution part. So, if you see here aniline cannot be prepared, they ask you cannot. Okay. Now, if you see the fourth option, that is potassium salt of phthalimide treated with chlorobenzene. See, in chlorobenzene, this is not possible because this one is not attacked by any nucleophile. Okay. So, this option number 4 we can use it. If you see the option number hydrolysis of phenyl isocyanate with acidic solution, yes, this is possible, this is true. Degradation of benzamide with bromine in alkaline solution, this is also true. Reduction of nitrobenzene with hydrogen, yes, this is also true. But if you see option number 4, potassium salt of phthalimide, okay, this is not possible. Okay, this is not the option, this is a false statement. So, they only ask you which is the cannot be prepared. So, fourth number option is the correct answer of your question number 133. So, now we are moving to the next question, that is question number 134. So, question number 134 is on your screen. Two possible stereo structure of CH3CHOH dot COOH which are optically active are called. So, now we are moving to the solution part. So, first draw the structure, how it's look. Okay. So, this one we can write like this, this is OH CH3 H on this side and COO on this side. Now, if I draw the mirror image, what will happen? OH is on this side, COOH and H and CH3. So, these two are an enantiomers. Okay. So, which is optically active compound, means non-superimposable mirror images will produce, and these isomers are called as enantiomers. Okay. So, option number C is the correct answer of your question number 134. So, this question is basically come from your stereochemistry part of your class 11 NCERT. So, now we are moving to the next question, that is the last question, question number 135. So, question number 135 is on your screen. The correct statement regarding defect in crystalline solid is. So, this question is come from your solid state of your class 12 NCERT. So, now moving to the solution part. So, they ask about which is the correct statement. Okay. They ask about the correct statement regarding defects in crystalline solids. So, Schottky defects have a no effect on the density of the crystalline solid. So, this is a false statement. Okay. This is not the correct statement. Frankel defect decrease the density of crystalline solids. This is also a false statement. Now, Frankel defect is a dislocation defect. Yes, this is a true statement. Okay. And Frankel defect is found in halide. So, this is also a false statement. So, option number 3, Frankel defect is a dislocation defect, and these things you have to find it out in the solid state chapter of your class 12 NCERT. Okay. So, option number 3 is the correct answer of your question number 135. So, students, today we study lots of PYQ questions and we try to solve it by using our chemistry knowledge. Also, we try to solve it by using small tricks. So, next class we are going to try more solutions and we are more focusing on the conceptual basics of chemistry. So, till then, keep learning and keep revising and hunting for that knowledge.
Ampullary isthmic junction is this portions, and after this what happened? This is the endometrium layer. So the sperm come in contact here, and here the ovum get transported to this region, and after that in this region the fertilization take place.